Hi, my name is Ronnie and welcome to my continued series on practical concurrency C++14. Today I'm not going to be looking at a huge amount of concurrency, but it will show you a building block that you can use to potentially make things concurrent later on. One of the key simplest things in C++ are variables, and probably most people are thinking, well, how can you make variables concurrent? Well, the initialization can be done quite interestingly in C++14. You want everything to be const as possible. And this is very much towards the functional approach where you want everything to be constant and you want everything to be declarative, and that's kind of the direction C++14 appears to be going in. If you want another example of that, try Rust, which also has everything const by default, which I think would be awesome to have as a switch in C++, but we don't. But anyway, regardless of that, let's have a look at a simple loop and see how you can declare it as const. And the key to all of this is functions and lambda functions. So this is a very simple loop which just creates a histogram of values as it iterates over this string. So I think it tries to find how many commas there are based on this known set of identifiers that could be separators. I'm using it as part of a CSV parser later on, but you know, that's separate. That's the context behind this. So immediately when I look at this, anytime you see a for loop, you probably want to be thinking, what am I trying to get out of this? In this case, I'm trying to get out a list. I'm trying to get an array of values out, which is the histogram. So probably first thing that pops in my head is either a generate or a generate n. Or in this particular case, I think an accumulate would actually do it. An accumulate is like a fold in a functional language like Haskell. And fold is very versatile if you're at all familiar with any functional languages. So let me write this as a fold expression, or accumulate in this case. So, and that will make everything in this function const. So let's call it histogram. And histogram can be auto, so we can see if we can do this, and maybe a const expression this, but let's see. Accumulate, begin data, end data. I don't know what we're going to use as a starting point, but I have a fairly good idea. It's an fn2 in the IDE, so that means it's probably going to take 2 parameters, and I know what it's going to take. It's going to take an accumulator, it's going to take a value, and then let's see what we can do. Well, let's see what we had back here. Now this for loop has now been taken care of by the accumulate, so we're not going to have any problems with like off by 1 errors or anything like that. In this simple case, not a big deal, but it could become a more bigger deal later on. The value is going to be for each character here, so we know if that's the case. We can switch on that, and we probably want to, once we've done that, we want to return return the accumulator, which is the histogram with all the values in it. And this is probably our starting point because we want an empty list, empty array. There we go. We don't need that. Using Clang format to format everything. Compile that, see if it works. And we're done. I've created this really contrived example just to show you the ability of const and lambda functions. You can create a lambda function as an initialization step of your values. So again, here it's pretty contrived. I've taken that histogram as before, done a switch on the first character, and just return an arbitrary value depending on what value it is. And then that initializes it to a val. And again, the compiler can then look at it and go, okay, well, I expect it to be constant. And if you use it later on, you've effectively told the compiler to potentially compile this, optimize this away at compile time to come up with a single value. Here, everything is well known, so I'd almost expect this to be a single XOR type calculation in assembler. But obviously, we know that depends on how good the compiler is. But the point is by declaring things as consts everywhere and using lambda functions to do a lot of your initializations, you can often end up with a much more simpler, easier to reason about code and potentially more efficient as well, because the compiler knows what you're doing and it's a well-recognized pattern. Okay, thanks very much. That's all I'm going to talk about on variables, and let's move on to the next tutorial.